Hi, this is Rachel, and we're going to look at adding, subtracting, multiplying and dividing indices. So let's have a look at these questions here. We've got 6 questions and I'm going to go through them one by one. So let's start with this first one. So this is asking us to add 2x cubed plus 5x cubed. So it's asking us to add those together. So the first thing I'm going to do is I'm going to check that my indices for my x's are the same. So I can only add in this fashion if my letters are the same and my indices are the same. So I'm going to look at these. So I've got x cubed. Good, they're both the same, that means I can add them. So what this means is I've got 2 lots of x cubed plus 5 lots of x cubed. Now this is very similar to, for example, saying that I have 2 apples. Let me draw an apple, there we go, plus 5 apples. So this here, I've just replaced the x cubed with an apple. So 2 apples plus 5 apples gives me 7 apples. And because 2 lots of x cubed plus 5 lots of x cubed is the same as 2 apples plus 5 apples, I've just replaced that x cubed with an apple so I can put the x cubed back. So this is now 7x cubed. So when I'm being asked to add indices, I need to check that the letter's the same, the index is the same, and then I'm just adding numbers of lots of that. Okay, let's have a look at the second one. So I'm going to do the same thing. So I've got 2x squared plus 5x cubed. So my x's are the same, and I'm now going to look at the indices. So this is a 2, this is a 3. They're not the same. So my x2 and my x3 are not the same. So I can't add these together because x2 is not equal to x3. Okay. Moving on to this last one on the top. So this time I'm doing a takeaway. So I've got 7 lots of x5 minus 3x5. My x's are the same and my indices are the same. They're both 5. So I'm going to box those. So I've got 7 lots of that minus 3 lots of that. Again, I can think of it as 7 apples minus 3 apples. So if I have 7 apples minus 3 apples, it gives me 4 apples. But I'm not dealing with apples, I'm dealing with x to the 5. So it's 4 lots of x to the 5. And that is my answer for that. So that's adding and subtracting. Now, when we're multiplying and dividing, we've got slightly different rules. So here I am multiplying 2 terms. I've got a to the 10 times a to the cubed, or to the 3, however you like to think of it. Now, my letters still need to be the same, but in this case my indices do not. That's because when I'm multiplying indices, what I do is actually something that looks like that. So if I'm multiplying a to 2 different indices, I will add those indices together. So I get a to the power of 10 plus 3, which is a to the 13. So a to the 10 times a to the 3 is a to the 13. And the reason this works, I'm going to show you with this next one, is due to quite a handy little reason. So a to the 2, a squared, that just means a times a, doesn't it? And a to the cubed means a times a times a. And when I'm multiplying a squared by a cubed, I'm multiplying a times a multiplied by a times a times a. So now I've got a line of a's all multiplied by each other. And that means that I've got 5 a's in total. So this is a to the 5, because it's a to the 2 plus 3. So that's what's going on in my indices, 2 plus 3, and it's because when I can write it out like this and it'll give me a to the 5. Okay, and then we've got this last one, which works in a very similar way. So it's a division, as you can see, and it works in the same way as the multiplication, except instead of adding the indices, we take them away. So here we've got B12, and because it's division, I'm taking away 4. So B12 minus 4, which gives me B to the power of 8. So when I'm multiplying, I'm adding my indices. When I'm dividing, I'm taking away my indices.